Hello everyone, hope you guys are doing great. In this session, we are going to take up a new project. As the title suggests, we are going to work on the snap fit simulation. Our objective is to calculate the force required to push the insert into buckle and pull it out from the buckle. Insert and buckle are made up of a plastic component and both are 5 mm thick. All the fillets mentioned in the 3D image are of 2 mm. Here, the material properties of the plastic is given, where Young's modulus is 2800 MPa and Poisson's ratio is 0.35. Since density is not given, we cannot perform the dynamic analysis. So here, we will be performing the static analysis. Dimensions of buckle and insert are given in the images. In the image, you can also notice the two positions of buckle and insert. In the first image, insert is at the disengaged position, and in the second position, insert is at the engaged position. Before we go to the Abaqus CAE, first let us quickly go through the theoretical aspect related to the snap fit. Please keep in mind, here the objective is to make you familiar with the overview of the snap fit. To prepare for the interview, you need to do more research on the snap fit from your side as well. Let us first try to answer what exactly are the snap fit. Snap fits are the type of assembly mechanism that enables the easy joining of component without the need for screws, nut and bolt, adhesive or other fastening method. It uses the elasticity of the material involved to create the secure connections. Snap fits are designed with the male features such as hooks, ribs or beads that interlock with the female component or the depression when the components are pressed together. In case of snap fit assembly, the locking will happen by pushing the insert into the buckle. That means for the assembly, we need to calculate the force which is required to push the insert into the buckle. Similarly, for the disassembly, we need to again pull the insert from the buckle. So again, for the disassembly, we need to calculate the force which will pull the insert from the buckle. On the right hand side, you can see the typical simulation of the snap fit where insert is pushed into the buckle and again in the second step, it is pulled out from the buckle. Snap fits are present everywhere. The typical applications include consumer electronics, automotive component, packaging, toys, and mostly wherever the plastics are there, in those cases we have the snap fits. You can go through all the applications present on your screen. Keep in mind, most of the focus of this course is on the automotive domain. So here under the automotive component you can check out, snap fits are used for the interior trim parts such as dashboard panel, door panel, strap buckles for the baby car seat and the console assemblies. As far as the material for snap fit are considered, thermoplastics are ideal for the snap fits because of its elasticity. Typical material include ABS, PC and nylon. Let us move on and see the typical type of the snap fit joint. Most commonly there are three types of snap fit joint: annular snap fit, cantilever snap fit and the torsional snap fit. In case of annular snap fit joint, you can see in the image. Here we have the circular protrusion on male part that interlock with the corresponding circular recess in the female part. The design is typically used for the cylindrical component, and the key feature that differentiates the annular snap fit is the circular ridge that determines the force required for the assembly and the disassembly. One of the most common applications of annular snap fits are the food container and the bushings. Second type of snap fit we have is the cantilever snap fit. Cantilever snap fit has the single beam that protrudes from one component and lock into the place of other. Cantilever snap fits are noted for their simplicity, cost effectiveness and the ease of use. In case of cantilever snap fit, the extended beam often has the tapered head that transitions into the hook-like shape, securing the connection. You will find lot of cantilever snap fit in case of the automotive interior trim. Next we have are the torsional snap fit joint. Torsional snap fit involves the twisting action utilizing the beam that act similar to the cantilever beam, but it is designed to rotate or twist under the force. This type is unique because it employs the torsional or the rotational force for the assembly. It is ideal for the temporary connection in which the components may need to frequently detach and reattach. You can note in the image, the red part is the location where the snap fit will get locked. In the image, there are two positions of snap fit shown. One is in the grey color which is at the engaged position and one is with the hollow white color which is at the disengaged position. Engagement or the disengagement of the assembly happen by twisting the arm about the spring location. This particular arm is mostly preloaded using the spring. I hope you guys will do more research on the snap-fit while preparing for the interviews. So let us meet in the next session where we will model the snap-fit joint. Till then, take care, goodbye.